Okay, so we're continuing on in our factoring process, and we're working on our boringly good factoring strategy, meaning we are building some steps that we'll do every single time, almost to the point where we've done it so many times we're bored with it, but as a result, we're going to be really good at factoring. Again, if factoring in the past for you has gone just fine, then you stick with what you know. Just get yourself unrusted, familiarize yourself with some of the special forms for two terms, what factoring by grouping is, which is what we're going to do in this lesson, and what you got good at in doing three terms. But if factoring in the past has been a frustrating thing for you and it never really quite clicked, then I would suggest that you try the method the way I teach it and see if that helps you. It's not the only method. The book does it differently. There's other ways to do it too, and you can get help. Come to class, you can get special tutoring through PCC resources, friends, classmates. There's lots of different ways to get good at factoring. So here's one way. See if it fits for you. If not, please bring your questions to class if you aren't sure where else to go and how to make this good for yourself. Okay, let's get to business here. This is the second part of 7.1. We did the first part looking at GCF before we even jumped into any of the other factoring pieces, and that's going to be our first step. We always check for the GCF. Always. First. Non-negotiable. That's what we check for first. And we covered that in 7.1a. And the second step that we're going to train ourselves in to get boringly good at factoring is to ask ourselves how many terms. And there's three possible answers. Either you're looking to factor 2 terms, 3 terms, or 4 terms. Again, this is the question after we've checked for the GCF. Now, if it's 2 terms, we're going to apply what we learned in 7.4 most. That was where we covered most of 7.4, the special forms. And those included difference of squares, difference of cubes, sum of cubes. We abbreviated those to DOS, DOC, SOC. Difference of squares, difference of cubes, sum of cubes. And reminding ourselves that there is no factoring for sum of cubes. Or I'm sorry, SOS, sum of squares. If you see something like x squared plus 25, yes, they're both perfect squares, but there is no way to factor that further. 3 terms we will look at in 7.2 and 7.3. So that'll come in just a little bit. 4 terms is what we're going to look at right now in 7.1, this B, this second part, and that is the factoring by grouping. Because once we get good at the factoring by grouping 4 terms, then the method I'm going to teach you is, instead of learning yet another way, most people feel like it's more of a guess and test way anyway for the 3 terms, we're going to learn how to factor 3 terms by converting to 4 terms, which we're going to learn how to do in this lesson, and then we can use factor by grouping to get to our answer. And just as a reminder, a review, factoring, what is factoring? Well, factoring is the undoing of multiplication, or the distribution, or the foiling that we would have done in chapter 6. When you FOIL something, you multiply the 2 terms by 2 terms and you ended up with 4, usually the OI piece connected to each other as like terms. You ended up with 3 terms. Well, now at the end of all this, we're going to be able to look at those 3 terms and get it back to where it was before we did the multiplication. That's what factoring is. Distribution, that's an example of when you factor, that's when you're looking for the GCF. You're undoing that distribution that has happened. And then any other version of multiplication of polynomials, binomials, trinomials, that's what we're looking at to undo for when we say to factor. So let's review just a little bit what we mean by GCF. Recall that a GCF, if you have something like 5x plus, say, a times x, Okay? What we were looking for is something that both terms have in common, and a term is anything separated by a plus or a minus. Remember, a minus is really adding the negative, so we can just say a term is anything separated by a plus. And looking for what multipliers that they have in common. And so for a GCF, we would pull that thing out in common, essentially divide both terms by that x. And then what's left behind, 5 plus a, is what we would then move on to factor further. At this point, all we've done is pull out the GCF, and we haven't looked to see if anything goes further. Or we applied the special forms. Again, we haven't looked to see how to factor any further yet. And of course, as a check, you would just, to check if you factored right, you would just redistribute or multiply that. Again, this is your final answer. This is where you're done, and this is just to check if the factoring is correct. You would redistribute. Usually this is done mentally in your head because you're just checking. So x times 5 plus x times a, yes, that gets you back to the original. Okay, so that would be your check. Now, today we're going to look at taking it up a notch, because we're taking now our knowledge of GCF and we're going to use that to learn how to factor by grouping. So what if you had, instead of 5x plus a to the x, you had 5 times something plus a times something, and what I would tell you is that that something is the same in both of those places. Okay, very similar to 5 times x plus a times x. The x was the same in both, and that was the GCF that we pulled out. So the GCF is equal to x here. Well, what if I told you 5 times something plus a times something, and all I told you was that that something is the same? What would the GCF be? It's equal to whatever is that same item, that even if it's in parentheses, even if it's long and complicated. Okay. For example, if it looked like this, 5 times x plus 3 plus a times x plus 3. This x plus 3 is the same in both, and this plus, here's where you have your two terms here, separates your two terms. I gotta make sure that my camera is catching all this. Yep, I have a little bit more space left, good. And in the sense then, that is the GCF. So the GCF is now x plus 3. That entire piece is what we get to pull out front. So the GCF here is what's in common with both. Even though it's bigger, they still have both in common. We pull out the x plus 3, and what's left behind is what we would expect to be left behind. You pull out the x plus 3 just like we pulled out the x, and the 5 was left behind. We pulled out the x, and the a was left behind. We're going to pull out the x plus 3 because that's what's in common to both, and what's left behind is the 5 plus a. And this concept is the basis of factoring by grouping. We'll do examples in the next clip.